Okay. So they call it linear programming, but it's basically it's basically just situations that need constraints. And so all the inequalities we practiced yesterday are what's going to be called constraints. So I thought it would be good for me to have just a fully written out one for you, like with the equations and everything. There's only 3 problems we're doing today. So when I say there's a lot of writing, I guess that's pretty much it. It's 3 of these. I mean, that's more writing than we normally do, but probably a lot less than you do for other classes. Ooh, that's too fat. How do we change the marker? Let's try that. So the inequalities that we wrote yesterday were called constraints. This thing is called the feasible region. And honestly, this is probably what I consider, yeah.
Is our test on Friday?
No, it's Monday.
Okay, good.
Yep.
Wait, are you making only like writing the whole like problem? Like the worst?
Why would you only write part of it?
Oh.
So yes, you're right. I should not be sarcastic. When I get sick, I get even more sarcastic than I normally am. Yes. So what I would do for this problem is write the whole thing down and just have it there as an example for something that you can look at when you get to the problems. Because what most students dislike about this section is that each problem is totally different, and so it's not something you can kind of just copy and change the numbers. So I'm doing what I can to get as many examples for you so that you have a lot of things to look at. And then this particular problem doesn't even have, like, it doesn't have an actual answer. This is just like the workings of a problem. The next one we do, we'll do the entire thing beginning to end. Now, as you're writing the problem, maybe what I should have said to you, Hadley, you don't necessarily have to write some of the strange details of the problem, like when it says 2 types of plants, blue lagoon sedum, that part doesn't really matter. You can call it whatever you want. You can just call it a blue flower. I mean, I've never even heard of sedum. I don't know if you guys have. I'm assuming it's that stuff that looks kind of like moss or grass or something. Okay, so I'm gonna guess a lot of you are getting close to finishing writing, or, just because everybody writes a little different. So I wanna talk about the information that's up there. Let's see. I need somebody who hasn't been called on in a while. Kelsey? You haven't been called on in a while? You don't wanna be called on? But I didn't even ask anything. How about I'll start with the easy stuff then. So on the bottom where it says B is greater than or equal to 0, R is greater than or equal to 0, and that stuff. The 4 equations, 4 inequalities. What do the B and the R stand for? Yeah, we'll just call it blue and raspberry. We're okay with that. I don't even know how to pronounce that word. Like, I've never heard of that word before. Okay, good. Yeah, I'm guessing said them, but I don't know. Yeah. Wait, Ava, you said you wanted to volunteer for her?
Yeah.
Okay. How come both of those say greater than or equal to 0? Perfect. You can't have a negative amount of them. So on all these linear programming questions, that's frequently going to be 2 of the inequalities. 2 of them are frequently going to be, the variables have to be positive. So that's a good way to start for you guys at least, because that's 2 of them. Let's see. Grant, I don't know if you've ever gotten rolled either, have you? Nice. Okay, good. Are you ready to help out now? Okay. The 1.2b plus 2r less than or equal to 600, where does that one come from?
The square feet that they covered.
Okay, so if you're reading through the problem, it basically only has 2 topics. The square feet and the amount of money. That's going to be the 2 equations. That's generally how these linear programming are going to be set up, is that the topics that you've given information on are going to be the equations. Perfect though. So since the one type of plant covers 1.2 square feet, you're going to multiply it by 1.2. And the other one covers 2 square feet. So there's 600 square feet on the roof. So the less than or equal to part means a combination of the 2 types of grass or whatever it is have to be smaller than the roof. You're not going to have more than the roof size. And then the last equation is pretty much just going to be the money, because that's the only thing left. It's the equation that represents how much money they have to spend. Who else hasn't gone much? Actually, Reardon, you haven't really ever gone. Why does it say less than or equal to 1,000?
You can't have more than 1,000.
Okay, you're told that you're going to spend less than 1,000. Now, I actually disagree partly with that one, because it's in the problem it says spend less than 1,000. To me, I don't think it should be a less than or equal to symbol. The way that that's worded is basically saying not going to spend 1,000, but less than 1,000. So if it words it somehow that it's less than or equal to, sure. I'm not going to be picky on that detail though. Okay, so we'll go with this. The picture you get once you draw everything is called the feasible region. It is the exact same thing as what we did yesterday. You basically just graph the solutions. So the way the feasible region works is if I pick any random point on the inside. So like, let's say I pick this spot right here. 100, oh, it's cut off on the bottom. 100 of the blue and 150 of the red. That combination would meet the requirements of all four of these. Okay? Now what we're trying to do though, the reason we're approaching this, actually let me erase the dot in the middle. When you graph a feasible region, the corner points of the feasible region are where you're going to find your maximum and minimum information. So, like, it might cost you the least amount of money, but cover the most. These are the combinations. These different combinations will cost different amounts. So we're going to test the corner points. I can't talk and write today. All four corner points we're going to test those to see which one would work the best. Now, the reason it wasn't brought up in this problem is because there wasn't I have it in the next one. It's called an objective function. It's basically the whole point of why you're trying to figure out the situation. The objective function is what you're trying to actually do. Okay, let's do the next one together. I know, this is where I apologize. It sucks to write these down. I've got no way around this. The good thing for you is like on the tests and quizzes, they're already written down. Homework, they're already written down. So basically the only time you have to write these down is in the notes. If you think you know how to write the equations pretty well already, you can certainly try to write them down on your own. And then as we talk about them, you can, fix them if you got something wrong. It's a good way to kind of test yourself. You can call the variables whatever you want. For right now, I'm just going to call them skilled workers and students. That's how I'll start my equations. Victoria, do you want the easy question to start with?
Yeah.
Okay. I mean, I wasn't expecting a no, but who knows? What should I write for skilled workers and students? If you look at the last example, it'll tell you exactly what to do. The first two equations are generally going to be the same. Wait, did you write anything down from the last one?
Yeah,
Oh, okay. What were the first two equations in the last one?
the B is
Yep,
greater than or
yep,
equal to 0.
yeah.
So it just would be like the scale of workers greater than or equal to
Yeah,
0.
because we can't have a negative number of workers. We can't have a negative number of students. Perfect. So we've got two of them. Now, all this does is really, it means that we can make our graph to the upper right-hand corner. We don't need to have all four quadrants. Okay, so then as I read through this problem, I see skilled workers cost $60 a day, students cost $40 a day, can spend no more than $14.40. So the next equation is basically going to be about money. Anybody feel like they can tackle that? I don't know if I should call on anybody or what. Yeah? Aaron?
Okay, so it would be 60 SW plus 40 S is less than or equal to 1,440.
Perfect. So $14.40 was the maximum amount of money we can spend. So we can't go past that. So it's less than or equal to. Okay, then the next sentence is kind of weird. It says 1 skilled worker for every 3 students. Now, this one's kind of different, so I'll just put this one up here. So 1 skilled worker for every 3 students. That kind of means that, let's see, I don't know, what order should I write these? Skilled workers, and we're going to compare them to students. My brain is half functioning today.
Students are greater than skilled workers.
Yeah, I was trying to. I believe it should be this. So
What does that say?
1/3 S. So there's going to be 3 times as many students as skilled workers. So if we want to kind of make them equalish, we're going to cut the number of students by 1/3. Or we could write 3 SW is less than or equal to S. And then the next sentence says only 16 skilled workers are available. So skilled workers has to be less than or equal to 16 because we can't have any more than 16. So these would be our constraints. And I don't know why I took the time to write them down because I already had them. Oh yeah, that one would have been greater than or equal to. That was my bad. This is where I was talking about my brain is only half functioning. So skilled workers would have to be greater than or equal to 1/3 students. Because you can have more adult chaperones or whatever. But that's the least number you can have. Okay, so these are called the constraints. The next thing I want to put up this equation is going to be called the objective function. Now to me, this is the hardest part for you guys as a student because the objective function information is written in the problem and it absolutely kind of feels like it should be one of these inequalities. But this is the focus of what you're trying to answer. So like at the very end when it says find the number of each type of worker that Brad should hire to maximize the number of packets. So the number of packets is your objective. And so that equation is going to be the objective function. And it says whatever, skilled workers can make 25 packets, students can make 18. So that's going to be called the objective function. And then we're going to graph it. Now, here's the annoying part. If you guys have graph paper, I would probably use it tomorrow. If you don't have graph paper, when you're doing the homework on these questions, because there's a good chance we're just going to take most of the hour to like do these questions together here. I am okay with you guys using Desmos to. Has anybody here not used Desmos? Okay, so you didn't use it last year? Okay, because I kind of figured it just depended on who you had for geometry. I believe in Desmos you can just write the equation without solving for y. Is that correct? Yeah, I mean we can test it out too. We can test it out after the notes. But you have to be able to graph pretty accurately to find these corner points. Like if you're just graphing on your notebook paper, these corner points could be way off. And then the problem becomes much more difficult to solve. So this one depends on accuracy, which is kind of annoying. Not even kind of annoying, it's very annoying. Because it's difficult to graph with accuracy. Okay, how are we so far? Do you guys need me to answer any questions? Do you need me to wait for you? Like, do you need me to wait for you to write any of this down before because we're not done with this problem. Yes, go ahead.
Wait, how would you graph that objective function on the graph? Or is it just those equations in graph form?
Yes. So if I graph these 5 equations, this is what I get. So I keep calling them equations on accident. Yesterday when we graphed the inequalities and we did all that shading, and our final section was like this highlighted section. That's exactly what this picture on the right is. So it's called the feasible region, and the feasible region is just the graph form of your inequalities.
Wait, but how did you get the p equals 18 x plus 25 y?
So the objective function? So the objective function is what you're trying to maximize or minimize. And in the problem it said maximize number of packets. So packets is what I was trying to, is my objective. It's my goal. And the sentence before it tells you skilled workers can make 25, students can make 18. Sometimes you guys will be given the objective function, sometimes you have to come up with it. I don't necessarily like how it's kind of a mixture of the two. Like it's usually easier to just kind of just get used to it, but it's a mixture of the two.
But how did you find it?
You mean?
Oh, wait, never mind.
Oh, okay, so when it said 25 packets per hour, that's 25 times skilled workers, and then 18 packets per student.
Okay, yeah, never mind. I didn't see that in the question.
And then what we're gonna do is take these corner points and put them into the objective. It's the goal of the problem. And that's what this is. So you're gonna take the corner points and test them into the objective function. I know, there's a lot of steps to this. Is this overwhelming or not? Yes, it's overwhelming?
A little bit.
If it makes you feel better, this is kind of why I planned this section for 3 days. I thought today would be like trial by fire. Just show you the problems. And then just have you try stuff. And then once you try them and kind of get used to certain parts of the problems, because that's what tomorrow's going to be. Tomorrow you're just going to try them. And then on Thursday, we're going to go through them together. We will try to answer questions on them and figure out the parts that you're getting stuck on.
Do we have homework tonight?
No. I mean, if you want to, you can, but no. Okay, you'll notice the combination of 24, 8. Well, I did a lot better than I thought using the mouse. Look at that. The combination of 24 students and 8 skilled workers gave you the most packets produced. And that combination of students and skilled workers met the criteria of all 5 of those inequalities. There's a lot of things going on, I know. Now, the good thing for you is you're just going to be given all this information in the paragraph. It's not like you have to come up with the information. Hard part is translating it into math. I'm sure some of you guys have questions, and I'm hoping too many of you haven't zoned out to go onto your phone yet. Phone/Chromebook. I know, it's difficult, especially it's 8:30 in the morning. No, 9 o'clock now. Now you should be awake, we're good.
I'm still half asleep.
Wait, did you say there was a fire drill?
Say what?
Wait, did you, I thought you said you were like an evacuation.
Oh, God, you had me worried that I totally forgot about one. People getting off of the bus today sounded like they had to do a evacuation of a bus drill. I think the elementary kids had to do it the other day. Do you guys want me to move on to a different question? It looks like nobody's trying to ask anything on this one. I'll put this one up. See what you guys can do. And if you're getting tired of writing down the question, just go right to writing the work. If you don't want to write down the entire question, just try writing down the equations. Just try writing down the info. Like instead of copying the paragraph. This paragraph is in the textbook, so if you want to look it up later, you could. You could write a note to yourself, see page 170, I don't know what page it is, I'm just going to make it up. Ugh. Oh, come in. I'll write down the first 2 parts. This one's slightly different than the other one. The other one we had to write that they were greater than 0, which is true. You can't have a negative number of bookshelves. But in the problem, it mentioned that you can't fit more than 8 of A, and you can't fit more than 12 of B. So I could write this as 4 equations if I wanted to. If I wanted to write A is greater than or equal to 0 and A is less than or equal to 8, I can. Otherwise, I combine them together to say it was in between them. Okay, then I'm going to do a money one. Minimize the cost. Okay, so minimize the...
Wouldn't the money be our objective function?
Correct. So because the minimize and maximize is your objective, definitely. So the cost is our objective function. The cost is, A is $200 each. So 200A plus 125B. Okay? So that's not even going to be part of our equations. The store needs 320 feet of shelf space. So shelf space is going to be my next equation, I guess. They did arrange these equations kind of differently, didn't they? Or the sentences, not equations. They arranged these sentences slightly different. So I'm going to have an equation that's greater than or equal to 320. Because if I can't get 320 square feet of space, it's kind of useless for this problem, and having more would be okay. And let's see, bookcase A is 32 square feet per, so this is going to be 32A, and then B is 16, so plus 16B. And that's all of the information that's written in the problem. So that's all I'm going to use. And then we get to graphing. So I'm going to try to graph. Okay, so let's do, I put A on the bottom, B on the side. It doesn't really matter how you put it. So A has to be, oh, that's black, shoot. A has to be greater than 0 and less than 8. So that arrowhead represents 8. So A is between those two. B is greater than 0, which is this line, and less than 12, which is this line. So all of my info has to take place in this square. And then my last one to graph is this. 32A plus 16B is greater than or equal to 320. Let me... So, do you guys remember the graphing where you cover up? So like if I put my finger over 32A, this would say B has to be greater than or equal to 20. Oh shoot, come on, really? So 20 is like up there. 20 is up here. If I cover up B, then this would say 32A is greater than or equal to 320, which would be A is 10.
Wait, where are you getting these numbers? Where did you get?
How about I solve for B, because B is like Y.
So wait, were you solving for B in your head?
Yes.
Okay.
How about I just solve for B and write it down? So subtract 32A. I'm solving for B because B is the same thing as Y. And then I'm going to divide everything by 16.
Wouldn't you just do, like, take away, so you take away 32A and then you divide by 16 on 320? And it would be...
Yeah, I was just having trouble doing math in my head.
Oh, okay.
2A. So I have a y-intercept of 20 and a slope of -2, which goes down to 10. So what I'm trying to do is I'm trying to give you the overview of the problem without taking too much time on details, and I get that can be an annoyance. So greater than or equal to would be shaded above. So then this tells me, well, let's use a crayon. Why not? Let's go with an orange crayon. I can't tell if that's orange. This shaded area right here is my feasible region.
Do you have to solve for A and B?
What do you mean A and B?
Well, you solve for B, right? You have B is greater than or equal to 20 minus 2A, and then you have to also solve for A in order to find that.
Are you talking about these points?
No, I'm talking about the equation.
Oh, no, this is similar to us writing y is greater than or equal to 20 minus 2x.
Okay.
If we used an x and a y to start with, we could have done that. And so you don't resolve it for x. What I am going to do is, we have time. I'm going to put Desmos up to show you guys how to use Desmos.
Will we be able to use that on the test?
Unsure. Probably, but unsure. I feel like if I remember correct, we have the test set up so that, like, you're not going to do an entire problem beginning to end. I don't think. Last time I gave this test, we would, like, I gave you the objective, I gave you the inequalities and wanted you to graph it. That was one question. There was a different question where I gave you a graphed one already and said which one would be the maximum info. Like, I gave you individual parts. Because the downside to these problems is if you get the beginning wrong, the entire thing's wrong. Now, let's test this out. Our equation was 32x plus 16y is greater than or equal to 320. How do I grab the center? I just grab it.
Oh, geez.
Okay. Were you guys okay seeing how to type that in? Like down on the bottom, there's the keyboard. Okay, I'm going to hit enter, go to a new equation. Now I want x to be between 0 and, was it 8?
Yeah.
Okay, enter. Now I want y up to 12. Now our goal is to find where all of the sections are shaded at the same time, which is this little triangle right here. Now I need to know where these lines cross. This is the reason for Desmos. I mean, you can check your inequality graphing if you want, but let's use this to find where they cross. So this way it's not overkill for everything to you guys today, which it might already be. So I can see they cross at 4:12 and 8:4. So what I'm going to do over here is I'm going to write that info. Holy cow, that marker is way too fat. 4:12, I already forgot the numbers. 4:12 and 8 something, 8:4. And then this one is kind of guaranteed to be 8 to 12. But if I want, I can go back to the graph to double check that.
How many questions of this type of question will be on the test?
It's like half of the test.
Wait, of this type of question?
Yes, but not one question. It's not going to be one question and a million parts from one question.
Okay.
We're trying to the goal here is to get you to learn all these parts individually and then be tested on them individually. Okay, we are almost done. I know you guys have been very patient because this is a tough section.
I know.
Last thing I need to do is I need to test these 3 points into my cost function. So my first cost function is going to be 412. So 200 times 4 plus 125 times 12. So we've got 800 and 1250? 2050? Somebody should definitely double check that. What is it?
125 times 12 is 1,100.
1,500? Okay, yeah, that's why I have you double check it. So it should be 2,500. No, good God. This cold is killing me. 2,300? Yeah, okay, thank you. I have lost my human calculator status. 200 times 8 plus 125 times 12. At least we know that that one is 1,500, 1,600, so 3,100?
And you want to find the minimum cost after all these, like after you do all the math. You have to-
Correct. So out of these 3, one of them is going to be the minimum. Like if I tested any point on the inside of the orange shaded region, it's going to be more than the minimum has to be on one of the corners.
Oh.
So the inner information, like the orange, would guarantee to be more. So 8 and 4. So obviously this one's going to be cheaper than the one above it. So 125 times 4 is 500. 500 and 1,600. 2,100. So the 0.84 would meet all the requirements of getting 320 feet of shelf space, plus it would be the cheapest on top of that. So this would be the minimum. Okay, that's a lot of information to absorb. What are we at? We get done at 28 today? Yeah, that's what I figured it would take about an hour to do those 3.